Welcome to Packet Sensei, your go-to resource for mastering networking concepts. I'm your AI teacher, here to help you understand networking. Dynamic Host Configuration Protocol, or DHCP, is a network protocol that makes our lives much easier when it comes to managing IP addresses on a network. Imagine if you had to manually configure the network settings for hundreds of network devices that connects to your network. It would be a nightmare. That's where DHCP comes in to save the day. DHCP automatically assigns IP addresses and other important network information to devices when they join a network. The beauty of DHCP is that it takes care of all this complicated stuff behind the scenes. When you connect your laptop or smartphone to a network, you don't have to worry about entering any network settings manually. DHCP handles it all, making sure your device gets a unique IP address and can communicate on the network without any conflicts. Welcome to the new era of video creation with HeyGen. Simply type your script to get started. At the heart of DHCP is the DHCP server. Think of it as a central hub that keeps track of all available IP addresses and other network configuration details. When a new device, which we call a DHCP client, wants to join the network, it sends out a request. The DHCP server responds by offering an available IP address and other essential information like the subnet mask, default gateway, and DNS server addresses. The DHCP process follows a sequence known as DORA, which stands for Discover, Offer, Request, and Acknowledge. This four-step process ensures that a client device receives a valid IP address and network configuration. Discover: when a device connects to a network and needs an IP address, it sends out a DHCP Discover message. This is a broadcast message aimed at finding any available DHCP servers on the network to help with configuration. Offer: upon receiving the Discover message, a DHCP server responds with a DHCP Offer message. This message contains an available IP address along with other configuration information such as subnet mask, default gateway, and DNS server addresses. Request: the client receives the offer and responds with a DHCP request message. This is essentially a way of saying, "Yes, I would like to use this IP address and configuration," to the DHCP server. Acknowledge: finally, the DHCP server sends a DHCP acknowledge message to the client. This finalizes the process, formally granting the client the lease to use the offered IP address and confirming the other network settings. DHCP uses broadcast messages, and broadcast traffic is restricted to a VLAN. In some cases, especially in larger networks, you might have a central DHCP server because you don't want a DHCP server in every VLAN. You'll need a DHCP relay. This acts like a messenger, helping to pass information between DHCP clients and the DHCP server when they are not on the same VLAN. You can configure a router or multi-layer switch to be a DHCP relay. And that's it for this video. Thank you for joining me today. If you have any questions or want to dive deeper into any of these topics, feel free to leave a comment below, and I'll be happy to help.